Dear students, after completing Arrhenius theory and Bronsted and Lowry theory, we are today here to discuss about Lewis concept of acid and base, or we have to see how Lewis explained the acidity of a compound or the basicity of a compound. In Arrhenius theory, we had two standards, H plus for acid and OH minus for base. And in Bronsted-Lowry concept, we had only one standard of H plus for explaining both acid and base. Here also we have only one standard, that is lone pair, for explaining both acid and base. What is an acid? Acid is a substance which can accept lone pair, that is a lone pair acceptor, and base is a substance who is capable of donating lone pair. Lone pair acceptors are acids and lone pair donors are bases. This is the simple definition introduced by Lewis in explaining the acidity and basicity of compounds. See the examples. Here ammonia. As you know, this molecule contains one lone pair. After completing the octet, this molecule, central atom of this molecule, contains a lone pair that is represented by two dots. At the same time, the molecule BF3, that is an electron deficient compound, that is an electron deficient compound in which boron has only 6 electrons in the valence shell. So, definitely boron should have a tendency to accept lone pair from the ammonia. Here we have shown that lone pair is donated by nitrogen to boron by an arrow mark. Actually, that is the coordinate bond. So, here lone pair donor is ammonia. So, it is Lewis base. Acceptor is BF3, that is Lewis acid. This is the condition in this example. Now, see another example. Here also we have ammonia having a lone pair and H plus. How many electrons are there in H plus? Actually, hydrogen atom contains only one electron. So, H plus is formed by removing this sole electron, and this H plus does not contain any electron. For stability, H plus now need 2 electrons, which is acceptable from ammonia. So, ammonia donate electron again act as Lewis base, and H plus accept it to act as Lewis acid. NH3 donate electron or lone pair to H plus and become NH4 plus, which actually we are calling as ammonium, not ammonia, it is ammonium ion. Now, what kind of compounds can be classified as Lewis acids, and what type of compounds can be classified as Lewis bases? To answer such a question, there are many conditions under which compounds can act as either Lewis acid or Lewis base. At first, we have to see what are Lewis acids, or what kind of compounds are expected to be Lewis acids. First one, all cations are Lewis acids. All cations like Li plus, Na plus, Ag plus, Hg2 plus, Cu2 plus, etc. are Lewis acids. Why they are Lewis acids? Ag plus, when combined with 2Cn minus, we will get a complex Ag Cn twice, 2 minus. Here cyanide is a lone pair donor. You have studied about coordination compounds in your plus 2 classes in chapter number 9, where cyanide is a anionic ligand. Cyanide is an anionic ligand capable of donating lone pair to Ag+. So Ag+ accept lone pair and act as Lewis acid. In the same way, other metal cations also act as Lewis acids, as they have the capacity to accept lone pair from the source from which it is available. Second class of compounds which belongs to Lewis acid is electron deficient compounds, just like BF3 in the previous example. BF3 accepted lone pair from the ammonia because of its electron deficiency. So BF3, BeCl2, BF2, BF3, BCl3, etc. are examples of electron deficient compounds, and few more examples you have heard in chemical bonding in your plus 1 classes. Third one is molecules having vacant d orbitals. Molecules having vacant d orbitals. Example SnCl4 or SiF4, etc. How they can act as Lewis acids? See the example. SiF4 plus 2F minus gives a complex SiF6 2 minus. SiF6 2 minus. Here F minus is a lone pair donor, and that lone pair is accepted by the silicon atom or central atom of this molecule silicon. So SiF4 accept or silicon accept lone pair donated by the fluoride to its vacant d orbital. Actually the configuration of silicon is 3D, configuration of silicon is 3s2 3p2, then 3D is vacant, 3s2 3p2 and 3D vacant. For bonding, what happened here is this electron, this paired electron, one of the paired electron excite here, then one fluorine bond here, second fluorine here, third fluorine here, and finally one more fluorine here, and we will get SiF4 by the bonding of silicon with 4 fluorine atoms. We will get SiF4. Even after the formation of the SiF4, you can see vacant d orbitals here. Am I correct? So these d orbitals can be used for accepting lone pairs from the next coming fluoride ligands or fluoride ions. They will donate lone pair to this vacant orbital and they form SiF6 2 minus. So these kind of compounds having vacant d orbitals are also capable to act as Lewis acids. Now you have to see the kinds of compounds capable to act as Lewis bases. Generally all anions are Lewis bases as they can donate lone pair. Example OH minus, Cn minus, Cl minus, F minus. Generally all the negatively charged ligands, simply we can say like that, all the negatively charged ligands can act as Lewis bases, and also neutral molecules having lone pairs like water, ammonia and derivative ammonia. Derivative of ammonia means they are organic amines, CH3NH2 CH3, CH3NH, and like that. Primary amine, secondary amine, or tertiary amine. All the amines contain lone pair, and there are lots of compounds. There are lots of neutral molecules having lone pairs with us. All of them can act as Lewis bases, as they are capable of donating lone pairs. Limitation: it is a more generalized concept, cannot be applied in specific cases, and they cannot explain the relative strength of acids and bases. The relative strength of an acid and base is dependable upon the ease with which it can donate H plus or accept H plus, that we have discussed in Bronsted-Lowry concept. Such kind of a comparison is completely impossible in this concept. These are the major drawbacks of this theory of Lewis. Now we have to see Lex Plot concept. This is our third concept after completing Arrhenius, BL concept, and Lewis concept. We are now in Lex Plot concept. What is the standard here? Here our standard is O2 minus. O2 minus means oxide ion. What is an acid? Acid is oxide ion acceptor and base is oxide ion donor. Oxide ion acceptor and oxide ion donor. Come to this example, CaO plus SiO2 gives CaSiO3. This equation you have seen in metallurgy. Here what actually happens is that here Ca2 plus and O2 minus. This is the ionized form. This O2 minus is transferred to this compound. Then SiO2 after combining with one more O2 minus become SiO3. 2 minus and Ca2 plus. We will get calcium silicate. During the slag formation, this kind of reaction you have seen, especially in the extraction of iron. In the extraction of copper metal, you have seen an equation like this, FeO. This O2 minus is transferred. This O2 minus is transferred to here. We will get FeSiO3. So, calcium oxide CaO is an oxide ion donor. Oxide ion donor. Here CaO is donor of oxide ion, so that is a base. Oxide ion donors are bases. SiO2 accept O2 minus, so it is O2 minus acceptor, hence SiO2 is basic, acidic. In the same way, FeO is base and SiO2 is acid. Limitations of this concept is suitable for ionic reactions only. This is a kind of ion transfer reaction. O2 minus is transferred from calcium oxide to SiO2. This kind of ionic reactions can be explained using this concept, but non-ionic or redox reactions cannot be explained using this concept. So far, what we have seen is that in Arrhenius concept, acid is H plus donor of a positive species. Base is a donor of negative species, OH minus. അതായത് പോസിറ്റീവ് ചാർജുള്ള എന്ത് കൊടുത്താലും ആസിഡ് ആവും, നെഗറ്റീവ് ചാർജുള്ള എന്തെങ്കിലും കൊടുത്താൽ അത് ബേസ് ആവും. ഇൻ ലോറി ആൻഡ് ബ്രോൺസ്റ്റഡ് കൺസെപ്റ്റ് H plus donors are acids and H plus acceptors are bases. അവിടെ പറയുന്നത് പോസിറ്റീവ് ചാർജ് ഉള്ളത് കൊടുത്താൽ ആസിഡാണ്, പോസിറ്റീവ് ചാർജ് ഉള്ളത് വാങ്ങിയാൽ ബേസ് ആണ് എന്നാണ്. ലൂയിസ് കൺസെപ്റ്റിൽ പറയുന്നത് ലോൺ പെയർ. വാട്ട് ഈസ് എ ലോൺ പെയർ? ദാറ്റ് ഈസ് എ പെയർ ഓഫ് ഇലക്ട്രോൺസ്. You know that the electrons have negative charge. So, lone pair possess negative charge. Lone pair വാങ്ങിയാൽ ആസിഡ്. അപ്പോൾ നെഗറ്റീവിനെ വാങ്ങിയാൽ ആസിഡ്. ഇത് തന്നെയാണ് ബ്രോൺസ്റ്റഡ് കൺസെപ്റ്റിൽ പോസിറ്റീവിനെ കൊടുത്താൽ എന്ന് പറഞ്ഞത്. പോസിറ്റീവിനെ കൊടുക്കുന്നതും നെഗറ്റീവിനെ വാങ്ങുന്നതും ഒന്ന് തന്നെയാണ്. നെഗറ്റീവിനെ വാങ്ങിയാൽ ആസിഡാണ്, നെഗറ്റീവിനെ കൊടുത്താൽ, അതായത് ലോൺ പെയർ കൊടുത്താൽ ബേസ് ആണ്. അതാണ് ലൂയിസിൻ്റെ കൺസെപ്റ്റ്. ലെക്സ് പ്ലോട്ടിൽ വരുമ്പോൾ നെഗറ്റീവ് ചാർജുള്ള ഓക്സൈഡ് അയോൺ കൊടുത്താൽ ബേസ് ആവും, ആ ഓക്സൈഡ് അയോൺ വാങ്ങിയാൽ എന്താവും, ആസിഡ് ആവും. അപ്പോൾ ആക്ച്വലി ഈ കൺസെപ്റ്റുകളെല്ലാം പറയുന്നത് ഏകദേശം ഒരു കാര്യം തന്നെയാണ്. ഒരു ജനറലൈസ്ഡ് ഫോമിലേക്ക് അതിനെ കൊണ്ടുപോകാൻ പറ്റുന്നതാണ്. അങ്ങനെയാണ് നമുക്ക് ഉസനോവിച്ച് കൺസെപ്റ്റിലേക്ക് വരാൻ പറ്റുന്നത്. ഈ പറഞ്ഞ എല്ലാ തിയറികളും കൺസൈസ് ചെയ്ത് പറഞ്ഞാൽ അല്ലെങ്കിൽ കമ്പൈൻ ചെയ്ത് പറയുമ്പോൾ കിട്ടുന്ന ഒരു ജനറലൈസ്ഡ് കൺസെപ്റ്റാണ് ഉസനോവിച്ച് കൺസെപ്റ്റ്. വാട്ട് ഈസ് എൻ ആസിഡ്? വെരി സിമ്പിൾ. ദേ ആർ സ്പീഷീസ് having the capacity to produce cations, H plus produce ചെയ്താൽ ആസിഡാണ്, അതാണ് പ്രൊഡ്യൂസ് കാറ്റയോൺസ്. ഓർ ടേക്ക് അപ്പ് ആനയോൺസ് ഓർ അക്സെപ്റ്റ് ആനയോൺസ്. ആനയോൺ അക്സെപ്റ്റ് ചെയ്യുന്നവരാണ് ആസിഡ്സ്. ആനയോൺ അക്സെപ്റ്റ് ചെയ്ത കേസ് ഉണ്ട്. എവിടെയാ? O2 മൈനസിലേക്ക് നോക്കൂ. O2 മൈനസ് അക്സെപ്റ്റ് ചെയ്താൽ ആസിഡാണ്. O2 മൈനസ് അക്സെപ്റ്റ് ചെയ്താൽ ആസിഡാണ്. ഫോർ എക്സാമ്പിൾ HCl gives H plus plus Cl minus. So it is cation producer. Cation means an ion with positive charge. So cation producer is acid. This is SiO2 when react with CaO gives CaSiO3. Here SiO2 accept anion, take up anion, accept O2 minus ion, which is an anion. Negative charged ion is anion. What is a base? They can produce anions. NaOH. See what happens. NaOH ionizes to give Na plus OH minus. OH minus is anion. That means anion producer is base. Calcium oxide when react with SiO2 forms CaSiO3. Here CaO donate O2 minus. So anion is donated. In the same way, NH3 plus H plus gives NH4 plus. Here NH3 accept cation. Accept cation means base. Then ammonia is a base. Now you have to see another equation. You can see in a yellow color. 2K. K means potassium plus Cl2 gives 2KCl. Okay. Here who is the base? Who is the acid? This is a kind of redox reaction in which transfer of electron takes place. 2K means potassium in zero oxidation state. Cl2 means chlorine in zero oxidation state, but in KCl, K plus 1, Cl minus 1. Potassium goes from 0 to plus 1 and chlorine moves from 0 to minus 1. From this change in oxidation number, we can understand that potassium donate electron and become a cation with positive charge, and chlorine accept that electron donated by the potassium and become negatively charged ion. Or simply, this is an electron transfer reaction. Electron is a negatively charged species. So if a species donate anion or produce anion or produce electron, here electron you can see, produce electron. Electron producers are bases. So potassium is a base because in this reaction potassium donated electron and Cl2 accepted the electron, accepted or take up anion or electron. So it is acid. So this reaction can be explained only in Usanovich concept. This concept does not cover all the redox reactions and acid-base reactions. That is the demerit or limitation of this concept. We have one more concept of solvent system concept. Solvent system concept. Here, what is an acid? A species in a solvent which can increase the concentration of cation of that solvent. ഒരു സ്പീഷീസിനെ നമ്മളൊരു സോൾവെൻറ്റിൽ ഇടുകയും ആ സ്പീഷീസ് ആ സോൾവെൻറ്റിൻ്റെ കാറ്റയോണിൻ്റെ കോൺസെൻട്രേഷൻ കൂട്ടുകയുമാണെങ്കിൽ അയാൾ ആസിഡാണ്. ഒന്നുകൂടി പറയാം, ഈ കൺസെപ്റ്റ് എക്സ്പ്ലെയിൻ ചെയ്യണമെങ്കിൽ നമ്മൾ കോമ്പൗണ്ടിനെ ഏതെങ്കിലും ഒരു സോൾവെൻറ്റിലേക്ക് ആഡ് ചെയ്യേണ്ടതുണ്ട്. ആ സോൾവെൻറ്റിൻ്റെ സെൽഫ് അയണൈസേഷനിൽ ഫോം ചെയ്യുന്ന കാറ്റയോണിൻ്റെ കോൺസെൻട്രേഷൻ കൂട്ടാൻ നമ്മൾ ആഡ് ചെയ്ത സബ്സ്റ്റൻസിന് കഴിയുമെങ്കിൽ അയാൾ ആസിഡാണ്. ഇനി ബേസ് എന്താണ് എന്ന് ഞാൻ എഴുതിയിട്ടില്ല, ഇത് തന്നെ ഒന്ന് മാറ്റി പറഞ്ഞാൽ മതി. എ സ്പീഷീസ് ഇൻ എ സോൾവെൻറ്റ് വിച്ച് ക്യാൻ ഇൻക്രീസ് ദി കോൺസെൻട്രേഷൻ ഓഫ് ആനയോൺ ഓഫ് ദി സോൾവെൻറ്റ്. സോൾവെൻറ്റ് സെൽഫ് അയണൈസേഷൻ നടത്തുമ്പോൾ പുറത്തു വരുന്ന ആനയോൺ ഏതാണോ ആ ആനയോണിൻ്റെ കോൺസെൻട്രേഷൻ ഇൻക്രീസ് ചെയ്യാൻ കഴിയുന്ന സ്പീഷീസിൻ്റെ പേരാണ് ആ സോൾവെൻറ്റിലെ ബേസ്. ഓക്കെ, അപ്പം നമ്മൾ ആദ്യം എക്സ്പ്ലെയിൻ ചെയ്യുന്നത് വാട്ടർ എന്ന സോൾവെൻറ്റ് വെച്ചിട്ടാണ്. വാട്ടർ എന്ന സോൾവെൻറ്റിൻ്റെ പ്രത്യേകത അറിയാലോ. അത് സെൽഫ് അയണൈസേഷൻ നടന്നാൽ എന്ത് കിട്ടുമെന്ന് നോക്കൂ. വാട്ടറിന് സെൽഫ് അയണൈസേഷൻ നടന്നാൽ കിട്ടാൻ പോകുന്നത് H2O plus H2O gives H3O plus plus OH minus. ഹൈഡ്രോണിയം അയോൺ എന്ന ഒരു കാറ്റയോണും OH മൈനസ് എന്നൊരു ആനയോണുമാണ്. അതായത് പറയുന്നത് ഇങ്ങനെയാണ്, ഈ വാട്ടറിൻ്റെ കാറ്റയോണാണ് ഹൈഡ്രോണിയം അയോൺ, ഈ വാട്ടറിൻ്റെ ആനയോണാണ് OH മൈനസ് അയോൺ. അത് സെൽഫ് അയണൈസേഷൻ്റെ ഇക്വേഷൻ എഴുതിയാൽ മാത്രമേ മനസ്സിലാവൂ ഏതാണ് കാറ്റയോൺ ഏതാണ് ആനയോൺ. ഇനി നമ്മളൊരു കോമ്പൗണ്ട് വാട്ടറിലേക്ക് ഇടുമ്പോൾ if that compound is capable to increase the concentration of H3O plus, then that compound is acid. If that compound is capable to increase the concentration of OH minus, that means anion of the solvent, then that compound is considered to be base. Example, HCl if added to water, you will get H3O plus and Cl minus. When we are adding HCl to water, you can see there is an increase in the concentration of H3O plus, which is the cation of water. Increase in the concentration of cation of the solvent, and HCl is acid. Then HCl is acid. If ammonia is added to water, we will get NH4 plus. That means 1H plus is transferred to here, then NH4 plus and OH minus. Here, by adding ammonia to water, concentration of OH minus increases. Okay? Therefore, ammonia is a base. OH minus is the anion of water. So, in water, ammonia is a base, as it can increase the concentration of the anion of water, OH minus. Now, if we have ammonia as the solvent instead of water, what actually happened? To explain this concept, first you have to consider the self-ionization of ammonia. NH3 plus NH3 gives NH4 plus NH2 minus. 1H plus is removed here. Sorry, 1H plus is added. 1H plus is added to this ammonia, and it become NH2 minus, and this become NH4 plus. So cation is NH4 plus, anion is NH2 minus. If HCl is added to ammonia, this H plus is added to ammonia and become NH4 plus and Cl minus. So in ammonia, HCl increases the concentration of NH4 plus, not NH2 minus, NH4 plus the cation. So it is acid. H minus if added to NH3, we will get NH2 minus and H2. NH2 minus increases the concentration of anion of the ammonia. So in ammonia, H minus is a base. This concept solely depends on the auto-ionization of solvents. So some solvents like SO2 who does not have the capacity to undergo complete auto-ionization, in such solvents, this explanation will be difficult. Acidity and basicity cannot be explained easily. These are the fundamental disadvantage of this theory. So far we have discussed many concepts. Around 6 concepts: Arrhenius, Lowry-Bronsted, Lewis, Lex Plot, Usanovich, and finally solvent system concept. I think you have studied all these things in better. Thank you.